Welcome to Cambridge IGCSE Physics, Lesson 11.1, Energy Stores. Today we explore the fundamental concept of energy storage in different forms, a core topic essential for understanding energy transformations in physics. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, state that energy may be stored in different forms. This is fundamental to understanding energy conservation. Second, identify kinetic, gravitational potential, chemical, and elastic energy stores. These are the most common forms you'll encounter. Third, identify nuclear, electrostatic, and internal thermal energy stores. These complete the full range of energy storage types. These objectives align with assessment. Objective 1, testing your knowledge, and assessment objective 2, testing your application skills. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, energy stores, which means different ways energy can be contained in objects or systems. Think of these as energy containers. Second, kinetic, which means energy possessed by moving objects. Any object with velocity has kinetic energy. Third, gravitational potential, which means energy due to position in a gravitational field. Objects higher up have more gravitational potential energy. Fourth, internal thermal, which means energy from random motion of particles. This relates to temperature. Understanding these terms precisely is crucial for Cambridge IGCSE success. Let's explore kinetic and gravitational potential energy stores. Kinetic energy is the fundamental energy of motion. The definition states, energy possessed by any object with mass and velocity. Mathematically, we express this as Ek equals 1/2 mv squared, where Ek represents kinetic energy, measured in joules, m represents mass measured in kilograms, and v represents velocity measured in meters per second. Gravitational potential energy uses the equation Ep equals mgh, where h represents height measured in meters. The diagram illustrates both concepts. The moving car demonstrates kinetic energy with velocity 20 meters per second, while the elevated ball shows gravitational potential energy due to its height h above the reference level. Now we examine chemical and elastic energy stores. Chemical energy store refers to energy stored in chemical bonds between atoms and molecules. Examples include food, which provides energy for our bodies, fuels like petrol, and natural gas, and batteries which store electrical energy chemically. This energy releases through chemical reactions such as combustion or digestion. We measure chemical energy as energy per unit mass in joules per kilogram. Elastic energy store means energy in stretched or compressed objects. The formula is E elastic equals 1/2 kx squared, where k represents the spring constant and x represents extension or compression. The diagram shows a battery demonstrating chemical energy storage and a compressed spring showing elastic energy storage ready to be released. Let's examine the remaining three energy stores. Nuclear energy store means energy stored in atomic nuclei, the central core of atoms. Examples include nuclear power stations, which generate electricity, radioactive decay, which releases energy naturally, and nuclear weapons, which release enormous amounts of energy rapidly. Electrostatic energy store refers to energy due to electric charges being separated or accumulated. Examples include charged capacitors in electronic circuits, static electricity you feel when touching metal after walking on carpet, and lightning, which releases massive electrostatic energy. Internal thermal energy store means energy from random motion of particles within substances. This directly relates to temperature. Higher temperature means particles move faster, so more internal energy is stored. Understanding these three stores completes your knowledge of all major energy storage forms. Let's work through our first example, calculating kinetic energy. The problem states, calculate kinetic energy of a 1200 kilogram car traveling at 25 meters per second. We are given mass equals 1200 kilograms, velocity equals 25 meters per second. We need to find kinetic energy, Ek. Step 1. Write the equation. We use the kinetic energy formula, which is Ek equals 1/2 mv squared, where Ek is kinetic energy, m is mass, and v is velocity. Step 2. Substitute the values. We write EK equals 1/2 times 1200 kilograms times 25 meters per second, all squared. Step 3. Calculate. 25 squared equals 625. So EK equals 1/2 times 1200 times 625. Step 4. State the answer. The result is 375,000 joules, or 3.75 times 10 to the power 5 joules to 3 significant figures. Example 2 applies gravitational potential energy calculation. The problem is, find gravitational potential energy of a 2.5 kilogram book on a shelf. The data shows mass equals 2.5 kilograms, height equals 1.8 meters, and gravitational field strength G equals 9.8 meters per second squared. Now we analyse. First, use the formula. We apply EP equals mgh, which gives gravitational potential energy. Second, substitute values. We write EP equals 2.5 kilograms times 9.8 meters per second squared times 1.8 meters. Third, calculate step by step. 2.5 times 9.8 equals 24.5. Then 24.5 times 1.8 equals 44.1 joules. Fourth, round appropriately. Since our data has 2 significant figures, the answer is 44 joules. The diagram shows the book at height h above the reference level, with gravitational force acting downward. Developing skills in energy store identification is crucial for exams. Let's analyse scenarios systematically. First scenario, a moving bicycle. This demonstrates kinetic energy store because the bicycle has mass and velocity. The key indicator is motion. Second scenario, a stretched rubber band. This shows elastic energy store because the rubber band is deformed from its natural length. Look for stretching or compression. Third scenario, hot coffee. This contains internal thermal energy store because the coffee has high temperature, meaning particles are moving rapidly. Temperature is the key indicator. Fourth scenario, food on your plate. This represents chemical energy store because food contains molecules with chemical bonds that release energy during digestion. For exam technique, look for keywords. Moving indicates kinetic, height indicates gravitational potential, temperature indicates internal thermal, and deformation indicates elastic energy stores. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, a 0.5 kilogram ball moves at 10 meters per second. Calculate its kinetic energy. This tests your ability to apply the kinetic energy formula directly. Question 2 is intermediate level. It states, list 3 energy stores present in a compressed spring on a high shelf. This requires you to identify multiple energy stores in one object. Think about position, deformation, and any other factors. Question 3 is advanced level. The question is, explain why a hot moving car has multiple energy stores. This tests your analytical skills in identifying several energy stores simultaneously and explaining each one. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world through energy store applications. In renewable energy, wind turbines demonstrate energy conversion by transforming kinetic energy of moving air into electrical energy for our homes. The rotating blades capture kinetic energy and convert it through generators. In transportation, hybrid cars showcase multiple energy stores. They store chemical energy in batteries and kinetic energy in their motion, switching between energy sources for efficiency. In safety systems, car crumple zones are designed to absorb kinetic energy during collisions, converting the car's kinetic energy into deformation energy of the metal, protecting passengers. Career-wise, this knowledge leads to roles as energy engineers, designing efficient systems, automotive designers, creating safer vehicles, and renewable energy specialists developing sustainable solutions. Understanding energy stores is crucial for our sustainable technology future. Let's review the solutions to build confidence. For question 1, the kinetic energy calculation. EK equals 1/2 mv squared equals 1/2 times 0.5 kilograms times 10 meters per second, all squared. 10 squared is 100, so we get 1/2 times 0.5 times 100 equals 25 joules. For question 2, the compressed spring on a shelf has 3 energy stores. Elastic energy, because it's compressed. Gravitational potential energy, because it's at height. And internal thermal energy, due to its temperature. For question 3, a hot moving car has multiple stores. Kinetic energy from its motion. Internal thermal energy from the hot engine. Chemical energy stored in fuel. And gravitational potential energy if on a slope. For exam success, always show you're working because marks are awarded for correct method even if the final answer is wrong. Include units in every calculation step. This is essential for full marks. When identifying energy stores, look for key indicators. Motion means kinetic, height means gravitational potential, temperature means internal thermal, deformation means elastic, and chemical bonds mean chemical energy. Use correct terminology. Say kinetic, not movement energy, and internal, not heat energy.